It's a single slit, number one. And number two, I never brought up wave function collapsing. And again, an antecedent to a diffraction pattern is a wave, a system of waves.
No, it
Simple as
isn't.
that. It's like having air pressure or pressurized gas without a container. It will fail.
Shut up.
If you have a diffraction pattern, you have a wave.
I'm done with you, Anon. You're annoying. Your endless
on mute.
bullshittery is now just annoying. You make up stuff. You're just annoying.
Hey, Nathan, can I ask the question for my sake? It might help
done
clear
with
it up. If waves always act like a wave, and they create diffraction patterns, if something changes that and it stops acting like a wave, that means there's something else going on, right? Is that what I'm hearing?
No, because
I'm not asking you, Anon. I'm not asking you. I'm asking Nathan.
I thought you were asking me. Sorry.
Oh, sorry.
Yeah.
I wasn't paying attention. I thought you were asking Anon, so I switched off for a second.
No.
Sorry.
No, I'm asking you. It's for clarity. If a wave should always act like a wave, right, at all times. But if for some reason it stops acting like a wave, which is the wave function collapse, that means there's something else going on. So it's not. Am I understanding that right?
It just means it's not a wave, and it never was. The part that was wave-like in any way, shape, or form was purely mathematical, and it's just describing probability distribution. So at no stage at any process was ever a wave.
Gotcha.
Nathan, would it be all right if
in the quantum eraser experiment, the wave function collapses on one of the detectors, right?
Yeah, upon acquisition of knowledge of which slit it went through, you can cause the wave function, i.e. the probability distribution that is the diffraction pattern, to collapse.
Right. So if it's a wave, as Anon is saying, then that wave should happen no matter what detector it's hitting, correct?
Well, it would just be a total mess. You know, the detector on the back wall, forget the slit detector, if light was coming at it like a wave, like a sea of light, then it would just be a total mess. You wouldn't have individual quantized particles hitting. You can't have that. You can't derive the frequency. You just can't do that. You need to be able to see when it hits, and then when it hits another location, and then when it hits another location, and another location, and another location, individual impacts. And once you've got those, you can then work out the frequency. You can work out and derive the wave function, the probability distribution of those impacts. Well, if Anon understood that you've got to have impacts and the probability of those impacts derived to give you the probability distribution, once you understand that, you can't in any way, shape or form shoehorn in the idea that it's arrived as a wave. It simply doesn't work. And not only that, you can't then derive the wave function if it was a wave. You couldn't derive that mathematical construct from it in the first instance. You need it to be quantized particles with individual impacts, with a frequency, to derive the bloody thing.
Well, we do see airy disks which look like waves. So when you're looking at airy disks which look like waves of light, it does kind of point to a light having some sort of wave, behavior based off the other waves that we see in everyday life that look kind of similar to those airy disks. And there's even problems with the particulate, notion of light being like a particle, in that if you
I don't know what looking at Aries disks is.
Can individual particles hitting individually create the pattern, as Nathan says, the probability? So as you see the imagery shown, the diffraction pattern, the middle area is most hit, and the sides to it are the next and the next and the next, and you could see it. Can that be caused by individual particles or only by a wave?
Well, you can
What
get
they
it
can't
back.
get their heads around.
Well, you can start to build it up with individual particles. So you could.
Right.
It's been done in that way. So you can fire individual particles. No, I've not done this. No, I don't own an argon pump laser. But you can, so I understand, fire individual quantized particles of light and then get a single hit at 0.3, and then do it again and get a single point of impact at 0.5, and then do it again and get an impact at 0.1. But at that point, with 3 impacts, you can't derive a full wave function from that. You need more. So then you fire a few more, and after a certain, I don't know how to do the maths in the top of my head, but within a given number of them, you could then derive your wave function from it. But at the point that you've only got 1 or 2 impacts, no, you can't. But you've still had light hitting the detector at the back. Well, that's still light, it's still travelled, it's still hit, it's still light. Can you derive a wave function from that? No. Will it build up a wave function? Or build up a pattern that you can derive one from with more impact? Yes, absolutely. But on the way to having a full enough picture of where the probability will lie, well, before it actually happens, it hasn't even existed as a probability. You know, we're getting beyond quantum level. Before it even exists as a probability, i.e. you haven't turned the bloody laser on, and then you fire 1 particle, well, you get 1 impact. Well, can you derive a wave from that? No. So you fire another one, 2 impacts. Can I drive away from that? No. By the time you're on to 150 of them, yeah, you can start to build up a probability distribution. Where's it going to hit next? Well, it seems like it's most likely to hit at 0.3, based on the probability distribution of the impacts thus far. So I'm going to say, most likely going to hit number 3. And guess what fucking happens? You fire the next one and it hits 0.1. Because it's only a probability. How likely is it going to hit number 1? Well, not very likely, because it's just hit number 1. So you fire your next beam, and shock and awe, it actually hits number 1 again. You know, it's just how it goes. So you build up that probability map, and then you can extract your mathematical probability wave from it. Your wave function. Purely mathematical, not physical, purely a derivative of the impacts that you've got, and the frequency they hit, and the probability and likelihood of where they'll hit next. Simple as that.
No, I get that. That was my very point. So then when the knowledge of the which path is introduced, all of a sudden, it doesn't behave that way.
Right.
What happened to the wave? How did it collapse? Why is it no longer a wave the way they think a wave should be? Whereas this is a wave only in the probability factor, a mathematical construct of it.
Well, once wave function collapse has happened, it goes through, say, slit 1, and hits directly behind slit 1, and that's your first bar. And if it goes through slit 2, it hits behind slit 2. So you know exactly where it's going to hit. Shock and horror, it hits behind the slit it went through. Well, you know, when you're firing them and you don't know which slit it's going through, rather than it just going through one and hitting behind the one that it went through, you end up with this random assortment, if not random, but a probability distribution of where it might hit next time. But there's no certitude to where the next impact will be until you know which slit it's going through. And then you have certitude. You know it's going through that one, it went through it. But then on the wall, instead of having this likelihood of where it's going to hit, it just hits directly behind that slit. Well, that in essence is wave function collapse, going from a probability of where it might hit to it's hitting here. Well, why is it hitting there? Well, because they know which slit it went through. And before they knew which slit it was going through, it could be going through one or the other. All they had was a probability of where it might hit. Where what might hit? Well, the quantized particle that they fired. Not where will we see this cross-section of interfering bloody waves in the ether? Who the hell has come up with this shite?
No, I don't see how you could explain it any more clear than that.
Well, I hope so, because that's where I'm going to round out the show. So with that, I'm going to say a huge, massive, enormous thank you to all of you who did tune in on the Nathan Oakley 1980 premiering stream, for hopefully smashing the super chat, liking, commenting, sharing, subscribing, and hitting that 1980 join button that we've just got. Massive thanks to all of you in the G Plus and Discord panels for making this after show possible. Be sure to check out nathanoakley.com and the Flat Earth Debate Forum to keep up to date with the community debate. I've been Nathan Oakley, and I'll see you all in the next video.
Oh, what a day! What a lovely day!